What I would like to do is to show the relationship between fascia and the second law of thermodynamics. There is a second comment which we can derive, is that there is no need to understand how an aspirin will work to demonstrate it is useful. And therefore, it is not necessary to have a diagnosis and a treatment logically related to produce good result to the patient. In other words, good results do not imply good diagnosis. The question was further studied in the mid-1800s by Rudolf Clausius, who expressed the second law of thermodynamics, whereby the energy will degrade with time and is less and less available to do some work. Ludwig Boltzmann wanted to measure the degradation of energy, that is, the amount of disorder which appears in the structures as the energy degrades. Entropy is a measure of that disorder. It measures the chaos. Since the universe moves from order to disorder, its entropy always increases. But there are situations where disorder can also create order. That will be the process of life. Let's consider the case of a pregnant woman. What she does is eat food and process disorganized particles of food into an organized structure, which is her baby. That does not violate the second law of thermodynamics, because this use of energy degrades overall. Hence, the result within the universe context will result in an increase of disorder. That will explain now the need for collagen. Once the fish lands on Earth 375 million years ago, it landed with a bunch of bones and muscles. However, those bones and muscles were now exposed to the gravitational field of the planet, and that made some changes possible, which represented an opportunity for the design and use of a new material, which is collagen. Now, why is fascia indispensable? Because muscles are gas guzzlers, and the animal must minimize their use for survival. Therefore, a structural material capable of transmitting forces without significant energy cost will be very advantageous. And collagen, which is called fascia, does it. First questions. What is the most efficient structure capable of building the animal using tensile components like collagen and muscles and compressive components like the bone? And the second question is, what is the impact of the Earth's gravitational field on the organizations of the fascial material? Let's first construct the animal. The power source is in the muscles. Then we have to transmit that power wherever it's needed, say in the arms. That is done by a combination of muscles and fascia. So we have two materials available to do that: bone, which can handle compressions, and collagen, which can handle tension. How do we design an animal on that basis? Well, tensegrity offered one solution to this problem. Tensegrity is a technique for building structures by decomposing forces into their compressive and tensile components. here is an example with this delta plane where the tension is sent through the cables and the compression through the rods. Here, shear is the enemy. It is the enemy because material that can resist shear is very heavy, much heavy and complicated than material that can sustain tension and compression. In 2007, Dr. Gimberto surprised many people by demonstrating that the geometry of the collagen network is not rigid and can rapidly reorganize itself under stress. And that provides a reasonable explanation as to how the musculoskeletal system can maintain its versatility in force transmission, food supply, and nervous control of the muscles. This is a serious challenge to the classical representation and modeling of biomechanical systems. The response of the tissues under stress should not be limited to the mechanical properties of the tissues, but should include the dynamic reconfiguration of the collagen network. And unfortunately, such a desirable analysis has not yet been done as shown in the literature. Well, it is time now to hear directly from the inventor of these ideas, which are now widely accepted. Thank you for your attention. Thank you.